Hello everyone, my name is Jonas Zehner. I work at the IFW in Dresden and I will give you a short introduction to kerr microscopy and in situ kerr microscopy. The kerr microscope, which you can see here, uses the Magneto optical kerr effect to measure magnetization curves and to visualize the magnetic microstructure. The Magneto optical kerr effect describes the rotation of the plane of polarization of light when it's reflected from a magnetized surface. And a kerr microscope is in principle a light microscope but uses linear polarized light. So the basic parts are a light source, which is here, a polarizer, which sits here to give linear polarized light, an objective here to focus on the sample surface, which lies on the sample holder here, and a camera to visualize the magnetic microstructure. So in our case, we use a magnet which gives an in-plane field, because we are interested in a sample which has a magnetization in the film plane, but it's also easily possible to change the magnet to a magnet which gives an out-of-plane magnetic field for samples which have a magnetization out of the film plane. It's also possible to measure at lower temperatures, and it's also possible to track some electrochemical reactions on magnetic thin films with a special electrochemical cell, which I come to in a second. So the information depth of kerr microscopy is around 20 nanometers for metals, but it can be larger for some metal oxides. But in any case, kerr microscopy is a surface sensitive technique, and the resolution limit is around 250 nanometers, as it is for standard light microscope. And here we look on a amorphous nickel iron sample, which is commonly attached to some products and articles to prevent shoplifting. So maybe some of you are familiar with these little stripes and have seen them on some products already. So in here you can see a pre-recorded magnetization curve. The acquisition time of a magnetization curve depends more or less on the signal to noise ratio USZ, and in this case the acquisition time was around 30 seconds. And kerr microscopy also allows to visualize the magnetic microstructure. What you see here is now the topography of the sample, and in order to visualize the magnetic microstructure, we first have to turn on the magnet. So what you hear now is the power supply of the magnet, and if we apply a magnetic field and use some digital help, we can visualize the magnetic microstructure. So these two colors indicate that the magnetization direction is in opposite direction. So for example, the black domains are magnetized in that direction, while the gray domains magnetized in the opposite direction. And for example, if we apply a field in one direction, then the magnetic domains which are magnetized in the same direction will grow, while the others will disappear. And the same is also true for the reversed way. Okay. And the observed domain patterns depends largely on the degree of anisotropy. And from a domain pattern and the domain reversal process, we can also obtain valuable information for the overall magnetization process by comparing, for instance, the virgin state with a state which is changed, for example, due to an electrochemical reaction. So, and if we want to probe the impact on the magnetic properties due to electrochemical reactions, we can use this electrochemical cell, which is already fully assembled. So you can see here the sample sitting in the middle, which is connected to the working as a working electrode, and then we can use two other electrodes, one as a counter electrode and this one as a reference electrode, for instance. And in order to do some electrochemistry, we attach the sample to a potentiostat, which you see here. Then we fill in the electrolyte like this. And it's also necessary to place a thin glass slide on top of the cell, because this ensures that we have a plane surface, and this is very good for the microscopy process. And in addition, we also have to use a special objective which has a coloring, so we can correct the light path which is disturbed due to the glass and the electrolyte. Right, and if we have done all this, we can build in the cell here and also measure, for instance, some reduction oxidation process here. So I hope you enjoyed the video, and if you have questions or are interested in measuring one of your samples, then don't hesitate to contact me or another group member. Bye bye.